Did you see this thing on the news? It's from a couple weeks ago, like around Valentine's Day. This 6-year-old wrote this letter to his teacher. My wife sent it to me a while ago, but this is from a 6-year-old. This note it says, "Dear Miss Jones, I am angry of you because you took 25 of my hummingbird bucks, all because I was talking to Connor. That's no big deal. I'm only 6. I can't be quiet all the time, and that makes you a thief and a crook. And you're going to hell, the real hell, the burning one, because you a thief. I worked hard for those bucks, and my only prayer in chapel today was that God get you to hell fast, super fast. And your new haircut is bad, real bad. Isaiah." That kid is awesome. You're going to hell, the real hell, the burning one. I worked hard for those bucks. Huh? Yeah. Your new haircut is bad, real bad. And then when you read the replies to that, some of a lot of people are like agreeing with the kid. He's like, look, this teacher doesn't understand how a reward system works. If he was talking in class, you don't reward him more, but you can't take back bucks he already earned. If you mess up at work, your boss fires you. He doesn't take back the last paycheck.
Yeah, I'll be taking that shit out of your
You're a thief and a crook. You're going to hell, the real hell, the burning one. I just want to be specific where you're going. Pray that God gets you there fast, super fast. Your haircut is bad, real bad. The clincher is that last part. After saying all that stuff, you decide to just turn on the haircut. The haircut is bad, real bad. I think that's great. Now, in my opinion, you think about all the crap that's in the news these days, now that's news. Right? That's not the kind of stuff you make up. You can't have like an opinion on that. That's just a 6-year-old telling it how it is. He took my hummingbird bucks. This is ridiculous. You could just feel the emotion in that letter. I wonder what you could spend hummingbird bucks on. Yeah, I just wonder what's the real value, the street value of these things. We should create a new cryptocurrency called hummingbird bucks. That's the name of the.
It's gonna grow up and be a founder. What's the name of that teacher?
Ms. Jones, and he's angry of her.
Yeah.
Dear Miss Jones, I'm angry of you. Oh, love that kid. Just love that kid. What class is this? 300? All right. And we're doing Towers of Hanoi. And then we need to talk about string tokenizer stuff. Okay. So I think the way we left it last class was we have our kind of ghetto version of this thing printing out, right? But we're supposed to, and I showed you how to do I/O, correct? So now we're supposed to ask the user for kind of a source destination tower, that type of thing. So if I do g++ star.cpp, okay, so it shows me my tower initially. So here's tower 1, tower 2, tower 3, and then I did a manual move to all the 3 towers. So I've kind of proven that I can do moves, but we're not currently putting any of the logic into whether or not a move is legal or not. Okay, so now what we want to do is we're going to go ahead and just add the next feature. We've already proven we can do manual moves, so now we want to start reading in from the user and asking them, the source tower and then the destination tower. So we should be able to see these things change. Okay, so, oh, it's asking for, oh, I did that at the very end. So there's one, just spit it back out. Okay. So we will go into driver CPP, which is where this stuff is currently happening. Now, realistically, if I was writing this, I would probably create a game object that actually drives all these things. So I'll go ahead and do that. So we're going to create a game.hpp. All right, and in my game.hpp, I'm going to include, I know I'm going to need IO stream, so I'll just go ahead and bring that in there. Is it using namespace std? I don't think we've done that yet, right? The using namespace thing. All right, so you'll see that here in a few minutes. And actually, maybe I wouldn't even write it in here. I'd put it in the next one, but I'll leave it in here for right now. So we're going to have a class called game. And our class game is going to have a public section and a private section. And actually, I wonder, is this guy not allowed in here? Yeah, there we go. Okay. So for our game, we're going to have 3 towers, right? And those guys can be private. That's just kind of happen inside of the game. So I'm going to steal those things from inside of driver. So here's my 3 towers. And these will be private variables in here. All right, in order for towers to be a thing, I need to include tower HPP. So now towers are a thing. All right. So these are fields that I'm going to keep track of. All right. Now, I'm going to also have a public constructor here, right? So this guy will be called game. It's not going to require any parameters for it to work. And when I build that game, I'm going to fill the towers with things. So realistically, actually, these guys will just be tower 1, tower 2. Actually, let me do, whatever. Just copy the whole thing. So I actually define the fields here. I'll give them values in the constructor. Okay, so let's leave our game HPP like this for right now. We'll come back and start adding things. So I'm going to create another file. This is going to be the game.cpp. All right, and this guy will include game HPP. All right, and one of the things we're going to have in here is our game, our constructor. All right, what that constructor is going to do is it's going to go ahead and give values to our towers. All right, so there's my towers. And now I can go back to what I originally had in driver. And I can go ahead and get those disks onto the tower. Because when we start a brand new game, we have all the disks onto the very first tower. So that's something else that should happen inside of the constructor. All right, now right now this guy, actually he does know about disk because tower knows about disk, and he's imported tower inside of game HPP. All right, so we've created some disks in here and added them to the very first tower, and then we want to maybe have a game be able to display board. So we'll create a public function here, void display board. And this guy's not going to require any parameters to work. We'll go ahead and implement display board. All right. And then we can go ahead and do, where's my driver? We already taught towers how to display themselves, right? So we can tell our towers to go ahead and display themselves here. All right, so now a game knows how to display itself, at least in its initial state. So then out here in driver, I'll go ahead and get rid of those things right there. We'll now just bring in game HPP. And we'll go ahead and create a game. The game is equal to new game. And then we'll say the game. This is a game pointer. This is going so slow. So then the game display board. And that should show us our board. Now let me show you something I hadn't here before. So up to this point, we've had to say std : thing if we wanted to use the cout. So we can put something in here called using namespace std. And then we should be able to say cin, cout, like that. Okay, so something is making this guy run crazy slow. I'm gonna kill off. I think it's something in maybe this browser. Hey, you hear that cooking? Oh, and I don't have my, maybe that's actually the problem. I'm in power save mode or something. Ninja'd. Yeah, I bet you that is it, because I have my brightness turned all the way up because I'm blind. So we'll see if this ends up being better, but it's already not. So these things ramp up a bit. Yeah, see, this Firefox on here seems to be, yeah, like, is it? I got plenty dedicated to it.
I usually I try to actually turn to
Okay. Well, whatever. We'll come back to it. All right. So I'll tell this guy to display. I created my instance of my game. I told it to display the board. We'll leave the other stuff in there. So we'll go out here. We'll compile this guy. What did I not do? Oh. Types may not be defined in a return type. Definition game 16. That was HPP. Oh, forgot my semicolon here. All right. So there's my game displaying its tower. So I just relocated some code to make this a little bit more convenient. Okay, so now we want to go ahead and play the game, and you can choose how you want to display your towers and things like that if you want it to be in a friendlier way, but we'll just call this okay. So we're going to go ahead and we're going to have it ask for a source and then a destination, and we can put it like in, we can call it tower 1, tower 2, tower 3, however we want to do, and then have if statements if we want. What I'm going to do is in here in game HPP, I'm going to create a, actually this will be an interesting thing. I'm going to create a tower pointer array. Let me use that syntax. Or do you do tower pointer pointer? Well, it should let me do this. Call that the towers. Nope, doesn't like it. So I'll have a tower pointer pointer, the towers. This is actually going to be fun. It's a pointer. A array is a pointer, right? So when you create an array, if I'm in Java, and I say int array AR is equal to new int array 5. AR is a memory address. It's a pointer that points to the beginning of that array. So that's this part of the tower pointer. And then what kind of values am I storing in there? I'm storing tower pointers. I'm storing a array of tower pointers. So I'm pointing to the beginning of a collection of towers where each element in that collection is a tower pointer, which points to an actual tower. All right, so this will let me show you allocate for this guy. I think I can actually just do, I think I could do it this way to make it look a little cleaner. I think that'll be the syntax for this, and I can even do that, I think, out here in the header. So this is going to be an array of 3 towers. All right, so I'll go back into game CPP, and I'll go ahead and say this, the towers at bucket 0 is equal to this T1. So I'll fill my array up with things. The towers at bucket 1, the towers at bucket 2. This is T2, T3. And then we'll replace this guy with bucket 0, this guy with bucket 1, this guy with bucket 2 for the displays. Oh, I had a ninja paste in there. So let me run this real quick, and which was that? CPP line 13. Oh, that's what happened. It wasn't a paste, it was a drag. All right, so that fills my towers up. All right, so there's the same logic. So what I did here is inside of game HPP, I went ahead and created a variable of type tower pointer array. So called the tower. So this is an array that holds 3 tower objects, tower pointer objects. If we're thinking about in Java terms, it's tower objects, which we know that objects in Java are always memory addresses. They're always pointers. C++, we have to specify that syntax. All right, this will allow me to access it as bucket 0, bucket 1, bucket 2, something like that. And in fact, if we want to have our naming convention a little bit better, maybe we actually name the towers, tower 0, tower 1, tower 2, so it lines up to what our arrays say. because when we play the game, we want to go ahead and have it ask us for the source tower. We want it to give a 0, a 1, or a 2. And then a destination tower, a 0, a 1, or a 2. And we want to do that, that move. All right. So we're going to go ahead and then inside of game HPP, we'll create another public method here called play game. Something like that. And we'll have play game. Go through and actually ask those questions, and so we'll go ahead and grab our code from driver, our IO code. So I'll just steal this from right here. We'll go into game. I'll just drop it in here for a second. I need to make sure I include IO stream. Did I put that in? I did. I already put it in game HPP. In game HPP, I also already have using namespace standard, so I have access to it. Realistically, I would probably put that in here to give us access to the STD namespace inside of IOStream. So namespace is like another level of organization inside of a Java package, or in this case, a C++ header file. Okay, so for play game, we're going to say enter, well, we'll probably do something like enter source tower. And we'll call this guy source. And then we'll cin to source. Jeez, it is still running. I have Firefox completely shut down, didn't I? Let's just shut it down. See if this gets it calming. Steam is taking up some resources apparently. It's probably like updating games or something in the background. Well, yeah, top. I could have done that, but I mean, I would have thought the stuff would have shown up here, but it is. It seems like it's fast on the Mac side, but it's not on here. So maybe a reboot for Linux is in my future, but we'll see how this goes. All right, so for play game, we'll get the source tower. We'll read in source, and I'm actually going to go ahead and give myself this variable source up above because we're going to be calling this over and over again. So I have source dest. Two different integers we're going to define. So we'll ask for the source. We will then ask for the destination. And read that into dest. All right, now these guys are coming in as actually, cin will read it in as an int. It'll convert it for us. Okay. So then what I want to do is I actually want to have it do the move. from the source to the destination. So what I'll say is I'll say this, the towers at bucket source dot pop. So I will remove an element from the source tower. And then what will I do with that element? I will do this. The towers at bucket dest push that element. So I'll push the element from the source tower onto the destination tower. Make sense? And for right now, I'll do that forever, just for testing purposes real quick. All right, so I created my couple of variables and then I constantly overwrite them as I play my game in perpetuity right now without my rules applied. So inside of driver, I just tell the game, actually inside of game CPP, we'll go ahead and show the game at the beginning. So we'll say this display board. So the first thing we always do is show you the board, then ask you what do you want to do with it. So now inside of driver, we'll say play game. So that's all that's in driver right now. Create a game, tell the game to play. All right, so enter my source tower. I choose, let's say 0. I want it to go to 1. It's moved it to 1. I say 0. I want it to go to 2. It's moved it to 2, so on and so forth. 0 to 1, which obviously is an illegal move, but we're not checking for that yet. But now if I say 0 again, now we get a segmentation fault because I just tried to pop off of an empty stack. Right, so we probably don't want to allow popping off of an empty stack in the ideal world. We're not going to really go and error check it because I want to get to string tokenization today. But we understand why we got the segmentation error. Don't try to pop something off a stack that doesn't have stuff on it to pop. Nah, users never make mistakes. We're learning to be a programmer, not a user. Good. You probably should. You probably should error check it. But we're going to be adding some stuff in. So if the spirit moves us, we'll error check it when we get to that. Okay, so we have our stuff now being able to interactively move around, though. Okay, so if we go back into our game now. We're making a lot of assumptions about this 1-2 punch right here, right? We're popping and pushing all in one fell swoop, and we don't really know whether that's an illegal move or not. All right. So what we'll go ahead and do is we're going to ask, how do we know whether a stack is empty or not? Here is our stack, which is our tower. How can we ask, is this guy empty? Go ahead. We can get the count. What else can we do? We can find out if peak is a thing. Synonyms, right? They both mean the same thing. All right. So when we ask for our source, we can have a couple of approaches here. I can ask for the source, then check to see if the source is a legal source right away before I ask for the destination. So I could go ahead and say, if the towers at bucket source peak, if that's a thing, then we're good. We're still kicking, right? If that's a thing, what do I want to do? I'll go ahead and read in my destination. Actually, what we could do is this. Let me just undo that. I'm going to go the opposite direction with this. I'm going to say if it's not a thing. So if you try to pop off of a source tower that's not a thing, this is already an illegal move, right? If it's already an illegal move, what do we want to do? Maybe print out illegal move and then maybe tell the loop to run again. How do we make a loop go on to the next iteration? Go ahead. Continue. All right, so if I'm in here, this means the source tower was not legal. So I'll go ahead and do a cout. Illegal source tower. Source. Throw the /n in there, and then we'll go ahead and continue, which will skip the rest of this loop and loop back up, display the board again, and then ask them for the source tower again. Kind of start the process of make your move again.
Is that like catch?
Well, it's not a try catch, because a try catch is looking for exceptions. This is us saying, well, I guess we can say this: we're trying to get something from the top of the tower, but we're not actually doing it. We're not actually grabbing it from the top of the tower. We're just looking at the tower. Like, is this going to work out? If it's not, I'm choosing to go ahead and give an error message and then continue. So maybe we could call this like the precursor to a try catch. Although C++ does support try catches. I've just been avoiding them at this point. They're in the language. Yeah.
There's other languages you can use
Sure.
like for error checking purposes, because then you could just simply put input. But since it's C++, it's simply you have to use the keyword continue.
No, continues in Python, C, Java. Yeah. Remember, we have kind of the three things related to, well, the two things related to loops. We have break and continue. Break gets us out of the loop. Continue just skips the rest of this iteration through the loop and starts the next one, next iteration. Yeah, those are language agnostic. It's in all of our languages that are based off of C. And then that third one that's kind of in the same family is the return statement, right? But that guy makes a method immediately end and optionally returns a value. So those are kind of our three power tools for getting out of Dodge quickly, right? I can break out of a loop. So even though this is an infinite loop here, my only way out is through a break right now. We might change that infinite loop here in a moment, but for right now, we're just going to say I want to repeat this for a while for our testing. All right, so we'll ask them for the source tower. I'll take a peek at the top of the tower. If I don't see anything there, then I'll go ahead and just kind of let them know that was not a good move. And then I'll continue, which will loop back up and will display the board again. Enter the source tower, so on and so forth. We might choose for display board to maybe do a cout something like that, just to give us a little bit of like a spacer between the displays of our towers so everything doesn't run together too much. This is all for our beautiful interface. All right, so if you picked a source that's not legal, we're going to skip. If I'm still alive here, we know that the source was legal. And if the source was legal, what do I do next? I ask them for the destination tower. Oh, did I just delete my destination? So I'll get my destination tower. I'll read into dest. All right. Now, if I know my source tower is accurate, then I can go ahead and here, let's we'll do it this way. So I'll get my destination tower. Is my destination tower always going to be a legal tower that I can push onto? Not necessarily. What does it mean for it to be legal? We know it's not going to be null. We're not going to check to see if they entered a value greater than less than 0 or greater than 2. But what does it mean for it to be legal?
Well, it has to follow the rules of telemarketing in that the larger circle can't be on top of the smaller circle.
Okay. Or it's also a legal move if what's the case?
A legal move, the medium one on top of the smaller one.
Or what if the tower's empty?
When the tower's empty,
It's free for all, right?
right.
Yeah, if the tower's empty, that's the trivial case, right? Nothing's currently on this tower. I can put whatever I want on there. All right. So we'll go ahead and read in our destination. So we know right off the bat that we're going to assume here that destination is a legal tower. It's one of our towers. We're not going to error check for them putting in a -4 or a 17 or hello, right? We'll assume they give us a legal tower, one of our 3 towers, 0, 1, or 2, but that might not be a tower we can make a move for. So we read in dest. Now we'll ask the question. Now, let's go ahead and create a disk pointer called temp source. And we're going to set temp source equal to this, the towers at bucket source dot peak. I want to get a pointer to it, but I don't want to actually remove it yet because I might need to put it back, right? I don't know if this is going to be a good move yet. So rather than take it off the tower and like, okay, I'm going to drop it down there. Oh, that's not allowed, so I'll go ahead and put it back. I just won't actually take it off the source tower yet. I'll just give myself a pointer to it. So I have a variable called, temp source, that allows me to easily reference the disk that's at the top of the tower I picked as my source, but doesn't actually remove it yet. Go ahead. It might. It probably does. Is that how we wrote it? I hope you're wrong. Let's assume you're wrong. I like to assume you're wrong. Ha ha!
Oh, I changed in my code to return it. Sorry.
In your defense, I think when we wrote our original stack, I think it did return an int. Yeah. We chose when we were creating our tower to have it return the actual disk. But definitely a good question to ask because that would have taken us down a very dark path. Well, I mean, not that bad, Brocker. You seem a little deer in the headlights. So you're sick?
I'm not sick.
Who's sick? I thought somebody. Oh, you're sick. What's going on? Flu?
Probably just being around a lot of people at the hack.
Oh yeah. So you're. Yeah.
It's just weak.
Weak immune system.
For sure.
Well, it is. We're all screwed, so it doesn't matter.
Yeah.
You just deal.
Where's the point?
Doesn't make any sense freaking out now. That ship sailed, where were we at? 45 minutes ago. Probably before that when you passed him in the hall. All right. So, in any case, let's go back here to game. All right, so I'll go ahead and just give myself a pointer to the top of my source tower, but I haven't actually removed the disk from the top of the source tower. Understand the difference between peak and pop. It's a distinct difference, okay? So I've just peeked at it, but I've given myself kind of a convenient little variable that I can, I don't have to like write this whole thing out every single time. I have a pointer to the top of that tower that I could use for some comparison here in a minute. All right, so now I have my source tower. I want to compare that guy to the top of my destination tower. So what I'll go ahead and do, and actually we can just do this. We can say if the towers at bucket dest peak. If not that is to say, if that's an empty tower, I'm good to go, right? If it's an empty tower, I can pull the trigger. And do my full move. Push on what I popped off the source. Because my destination is free-for-all empty tower. I don't have to check the rules. Else, apply the TOH rules. Old Roman style, of course. You don't like just putting random comments in your code? I used to put jokes in my code. And what I have seen from students is I get some nice commentary of the level of frustration at different points in their code. Yeah, it's been a little colorful than that sometimes.
The good comments won't explain why.
Huh?
The good comments won't explain why.
Yeah.
Oh. Well, I did explain why. I just said, of course.
That's not an explanation.
This is self-explanatory.
No, it's not. No, it's not.
I mean, your only two choices are Roman style or old Icelandic death style.
Oh, no.
Yeah, well, most people would, but this is a Christian university, so we went with Roman style, of course. Plus, it's biblical. The Romans are in the Bible.
Weren't they the ones that were?
Actually, you know what? I bet you there's probably some historical things, because this game's really old. I bet you the Romans did play Towers of Hanoi. There's probably some we could.
Did they actually use stone? Did they actually use like stone? Actual stones?
Yeah,
Like actual like heavy. Like,
let's hope they use stones and not something worse.
Well, no.
All right. So, if I'm in this else, we'll go ahead and apply the Towers of Hanoi rules, because I know that I definitely have a top. I have a peak on my destination tower, but I'm not sure if I'm allowed to do the move, right? So I'll ask the question. I'll go ahead and give myself a disc pointer called, and actually let me, well, I'll just do it here. It's fine. We'll call this guy temp dest, and he's going to be equal to this, the towers at bucket dest peak. All right. If you remember back when I first introduced stacks, I mentioned that the only two methods that are by design required for stacks are push and pop. You see how handy peak is. So I consider peak a requirement for towers or for stacks. It's just a very common thing that you want the top of the stack and might not want to remove it. That's a thing. All right, so I'll go ahead and grab myself a pointer to the top of the stack without removing it. Now I want to ask some questions. I want to ask, is my temp source, which I know is set currently, is that guy a smaller disk than temp dest? So if temp source get size, that's the size of that guy, is less than, actually, why don't we say this? Just so we skip the move. Well, actually, we haven't done the move yet. If it's less than temp dest get size, then it's a legal move, correct? And if it's a legal move, then I can go ahead and do the move. Make sense? Now, I could actually combine these things together where I can take that Boolean expression and I can say this or that. But I would need to set temp dest above there. So I have my destination. I'll go ahead and grab my source, grab my destination. Temp dest might be a null value, right? So I actually can replace this guy right here. I mean, what I have there is fine, but I can also just say if not temp dest. So if either there's nothing at the top of temp dest, or my source is smaller than the top of temp dest, if either of those are true, I can go ahead and do my move. Make sense? So I can combine it into a single if statement if that makes you happy, or I could have the if else structure that I had. Right? Only under those circumstances will I make the move. Otherwise, I might want to go ahead and, since I did it up here, give some commentary. Illegal destination tower. Now, do I have to continue here? I can continue. If I continue, it'll just start the loop over again. But am I doing anything else after this? I might want to be explicit about it and say, if this was an illegal thing, I'm done for this pass, go ahead and continue. That's not going to hurt anything, but we see that what does continue mean? It means skip the rest of this loop and loop back up. The rest of this loop is very uneventful. Make sense? Not a whole lot of stuff going on down there. So I can choose to recognize that and know that this continue isn't required here. Or I can just say, continue's not going to hurt. That is the move I want to make. If this was an illegal destination tower, I am done with this move attempt. Therefore, I will continue on to the next move attempt. We can be explicit about it. That's never going to be wrong. All right? So you can try to be fancy, or you can just be explicit about your decision making. All right, so we've either successfully made a move, and the next time through my board will be changed, or I will have gotten a little error message, and the next time through I will have to make another choice for a move. Either way, I'm doing another move. So now if we go ahead and run this, peak is a method. What's that? 29. Where were you on that one, Clancy? All right, so that's that's what my tower looks like right now. I'm going to go ahead and choose 0 as my source. I'll choose 2 as my destination. Okay, that worked. I'll choose 0 as my source. I'll choose 2 as my destination. We expect this to give us a bad move, right? So I'll choose 2. It's going to yell at us saying illegal destination tower. Oh, I forgot to change I have it in there. Let's just remember to do that here real quick, because I copied and pasted so this is actually dest. All right, but we'll keep going with our testing. That's arbitrary. All right, so now we'll go 0 to 1. That's allowed. And then I'll go ahead and go 2 to 1. Now I'm going to choose 2 as my starting point, which we also know is an illegal move. This will test our logic for our source. Illegal source tower 2 because it was empty, so it showed us the tower again. So I'll go ahead and choose 0, go to 2. Then I'll choose 1, go to 0, 1, go to 2, 0, go to 2. Now it should recognize that we have a winning board, right? What does it mean for there to be a winning board?
Either have 3 on the last one or the other 2 are empty.
Okay, you can ask it either way. You can say, are tower 0 and tower 1, are they empty? Or is tower 3 have a count of 3? Pick your poison. And this is, again, staying strictly to a 3-tower rule. If you went and looked at various Towers of Hanoi games online, you can have ones that give you the ability to have, like, multiple towers, and then instead of 3 discs, you can have 30 discs and stuff like that. So we're going to stick with a very basic thing so we can just ask the logical question. So we'll go into our code here. So instead of this being a while forever, we really want to say while there's not a winner, right? So while this, and actually we'll just write it to get done with it. So while the towers at bucket 2 get count is less than 3. Well, that's a true statement. Keep doing this stuff. As soon as that's not a true statement, we'll finish this loop. We'll see out winner. All right, so we'll go ahead and do 0 to 2, 0 to 1, 2 to 1, 0 to 2, 1 to 0, 1 to 2, 0 to 2, and there's our winner. Probably want to display the board one more time, but you know. All right, so does that solve the Towers of Hanoi homeworky stuff? I'll go ahead and display the board once more. All right, so questions about how we solved that? Not too bad. We're starting to get used to the pointers and C++ stuff and coming a little bit more naturally, not as intimidating anymore. Feels more like Java at this point. All right, so I'll go ahead and push this solution to GitHub. Isn't that so much faster than even Android Studio?
Yeah.
So we look at some things like this and we think that, oh, you know, that's not as friendly, but it's way more powerful. It's just better, right, Brocker?
Absolutely.
Yeah. Oh, by the way, I watched Art of Self-Defense again last night. I'm a free.
He hasn't seen Step Brothers.
Well, I mean, I'm going to call that as an okay thing. I'm not sure Step Brothers was one of Will Ferrell's best.
Oh, man, it's a good movie.
It's an okay movie.
Well,
Agreed.
have you seen Sherlock Holmes, the one that he...
That one's pretty good. Oh, I thought it was funnier. I thought it was
I
better.
was disappointed. I was just...
You just have bad taste, Clancy.
You just told me you didn't think... You told me...
The only thing worse than your taste in movies is your eye for code errors.
Here comes the bus.
Yeah, that soundboard
Here comes the
material.
bus.
What's this?
That soundboard material right there.
How is it?
Crafty and Clancy.
We got 53 minutes-ish was the timestamp for that one. All right, so what I want to look at now, dare we, actually, just for the sake of performance, let me go ahead and open this up on the Mac side for my Windows. So we're going to start using some built-in libraries for strings. Remember in Java we use something called a string tokenizer, or we use split. I think we use something like that to split strings apart. Okay. So I'm going to do C++ str toke, I think it is. All right, so built into C++, we do have a library called string.h. And there's a bunch of things in string.h to allow us to do stringy stuff with something called C strings. And we've already been used to working with C strings. We're just calling them strings. So notice this guy is a char string array, or we can also just say this is a char pointer called str. Those are synonyms with each other. Okay, I tend to use the pointer syntax. I only use an array syntax if I actually am creating an array like we did with our towers. All right. just real quick so I don't forget. Technically, we've been a little lazy in here. So under driver, at the end here, I should probably delete the game. Clean up that memory from it. Similarly, we actually have a deconstructor in C++ where we probably should tell the game to delete itself or clean itself up, because inside the game we have these towers that have been created and things like that. I'm pretty sure the constructor for that has like a little tilde thing in front of it, game. I think it's this. Right for it. So then inside here, we would go ahead and call delete this T1, delete this T2, delete this T3. Those are places where we use the new keyword. We probably should also go one more level down and clean up the disks that are inside the towers as well. Whatever. It would have been nice to put those in some nice pointers to quickly get to them. Otherwise, I'm going to have to just search through my towers real quick and look for disks. Theoretically, we should have had a winner, right? And the disks are all in Tower 3 or Tower 2. We're not guaranteed that's the case. So realistically, I guess we should say for int I is equal to 0, I is less than the towers at bucket 0, get count, I plus plus, and we'll say, well, see, that's going to break our tower anyways. We could have designed it differently. We'll just say getting rid of the towers is going to be good enough. I actually think it might be anyways. All right, so we'll just call this good. Let me run this again real quick. So there's our winner cleaned up. So I'll go ahead and push that. So technically, whenever we use the new keyword, we should clean up that memory ourselves. Or if we use one of the memory allocate things before the new keyword in like C, we should clean up the memory. Go ahead.
There is an automatic garbage collection you can import for C and C++, right?
Not by default, but it does exist now.
Yeah.
Yeah. So, but I would say as a C or C++ programmer, you shouldn't rely on that. Yeah. I mean, good programming practice would be to, if you make a mess, clean the mess up. Is the idea. All right, but if you take a language like Java, so getting back to the string stuff, you take a language like Java, where I've mentioned that Java is kind of a string-centric language. In that kind of language, we have a situation where the strings are treated almost like primitive types. All right, so we never had to import anything special to do fancy things with strings. They just kind of work. All right, well, there's a library called string.h, and I'm going to go ahead and just create a new folder for us out here. I'm going to do make dir shunting yard And then, well, we'll just leave it at this for right now. Inside of the shunting yard directory, that's going to be the next algorithm we're going to look at, is something called shunting yard that uses stacks and queues, but I'm going to introduce strings first. This isn't going to be for Thursday. It's going to be for over the weekend, but we'll at least get our structure sitting correctly there. So I'm going to go ahead and I'm going to open a directory. And we'll do shunting yard. All right, and I'll go ahead and create a file in here. We'll call this guy driver.cpp. And then I'll go ahead and I'll do an include string.h. And I'll include iostream.h. And then I'll say using namespace standard. You can actually do it this way. If you want to use namespaces only for a particular part of your program, I usually just say if I'm going to use a namespace, I use it throughout my program, but you might decide that you want to say I'm using the namespace standard only inside this opening and closing curly braces. Go ahead.
Why is it string.h? It's looking like it's not IO.
Oh, thank you. Sorry. Because IOStream has namespaces inside of it. So IOStream is a collection of header files, a collection of namespaces, where string.h is a much older animal. Actually, IOStream is actually older, but it's been refurbished since. So yeah, good point. This says give me access to a bunch of stuff. Inside of there, I have many namespaces. I can choose to operate inside of a namespace, or I can just do that thing where I said standard : : cout, that kind of thing. All right, so inside of this namespace, I'll have my int main, and then we'll go ahead and do a cout hello world \n. So I can't put main inside of that. I never write it that way anyways. All right, so let's just make sure this guy works real quick. So we'll do our G++ driver. Well, I usually do star.cpp, but in this case I only have one. And there's our hello world. So we have a working starting point for our program. All right, so now what we want to do is I'm going to go ahead and give myself a string. So I'm going to say char pointer s is equal to 123 plus 13 minus 2. Remember this guy from a while ago when we had something like our, what we call process expression? Was that in 200, I think? Where we had to split it up and then do the math and things like that. See, you guys are already excited. All right. So we're going to use something here called the string tokenizer. So here's our method header for this. We have something called string toke. And when this guy gives us is he gives us a, he'll return a char pointer. So what I give him is a char pointer for my string, and then a string with my delimiters in it. So for example, if I said, here's my my string, this is a sample string, and then I call string tokenizer on this guy, and I say, give me this tokenize on space, comma, period, and dash, right? What do you get? You spin through here, and the string tokenizer is going to give you the number of those tokens, or is going to give you each token each time you call it. All right, so if I call string tokenizer over and over and over again, what it does is it whittles down that string until you have a empty string inside of str. but string tokenizer has returned your partial string over and over and over again to split a string up. Go ahead. Printf is the C version of cout. It allows you to have like a formatted thing. You can use either of them. It lives in standard IO instead of IOStream. All right. Now let me do a C++ string split. Is that inside of string.h? Actually, you know what? Let's just do C++ string.h. All right, so here's stuff that's inside of string.h. Let's see what we got. Here's split a string into tokens. Well, I just did it. It's C++.com. I just did a search for C++ string.h to give me the documentation for it. Okay. Well, I just changed my tactic for the assignment for next time, but actually that's okay. This is a better assignment, I actually think, since you've already done this one before. All right, so just to show you how this works, we're going to go ahead and we're going to say, if we look at their example here, they're going to keep going until this guy finally gives us a null value. So we're going to, I'll assume there's a single string in there, at least initially. So I'll say, actually, I'll just do this infinite loop thing here. So I'll say while one, you know what, actually, let's just do char pointer temp string. So I'll actually do this as a do while loop, which is a loop that goes through at least one time. So I create a variable called temp string. The very first thing I'll do, am I actually going to give myself a char pointer delimiters, and I'll set this equal to plus minus times divide, like that. And I'll do something here. I'm going to say temp string is equal to string toke, which gives me a, I'm going to pass it current version of temp string. I'll pass it my current delimiters. So we look up here. That's what string toke takes, is the string and then the delimiters. The string I'm tokenizing and the delimiters I want to tokenize it on. It spits out the next token in there. I'll just ask a question if temp string. Actually, we can always just print it out. So I'll just say cout temp string. All right, so we should get a 123, a 13, and a 2 from this guy. Go ahead.
I think you have to take it as. You have to pass it.
Thank you. Okay, this is just a warning. It doesn't like, this is a string constant. It wants me to do it as that array thing. This should still run. No, doesn't. So it wants me to do this.
Guys, I can't take it anymore. Stop quizzing me.
What's wrong? I don't know.
It's working.
Well, except I never broke out of the.
Except, 123
So it got me the 123. So string toke didn't actually remove it. Where did the removed value go?
It's going forever.
Okay, that's fine. But it's not burning past it. This gives me my first thing. I print it out. That's the this. And I sent this guy equal to string toke on. So it just empties that string. Oh, so I guess we're loading up string toke and then giving it, then it keeps burning off the tokens. Instead, I'm calling it again. Well, I guess it doesn't necessarily matter. So the way string tokenizer works in Java is as you ask for the next token over and over again, it keeps whittling down this string. In this guy, what it does is it tokenizes it, but then it, after I do it the first time, string tokenizer has the thing loaded in memory. So then I can keep calling it again on nothingness, and it will give me the rest of the tokens. But what it doesn't give me is it doesn't give me the delimiters. So remember when we wrote process expression, we needed access to the, by our example here, we wanted the 123, the plus, the 13, the minus, the 2. We wanted access to all those things. So string tokenizer built into C doesn't give us that. So what we want to do is we want to write a class that does things to strings. Initially, we want it to at least give us a split function that will return an array of strings with all of the delimiters and all the strings and delimiters, substrings and delimiters. So by our example here, it should give us an array that has in it 123 plus 13 minus 2. That's what we want it to give us. If I were to give it this string here, we should have maybe a class called string factory or something like that I could pass that string to and then say split this on plus minus times divide, and it would give me an array of strings with those individual pieces that I can then work with. That make sense? All right, so that is for Thursday. Once we have the ability to split up a string, then we're going to look at the shunting yard algorithm on Thursday. Questions, comments, concerns, bribes? All right, I will see everybody on Thursday. Remember, today is student, faculty, staff, Bible study, God and grub. Go to the cafeteria, sign in. Take your lunch down to the terrace room. That's from noon to 1, but you can start eating your lunch down there now.